Hello guys, and welcome to another video on the GC4 YouTube channel. I'm Ulrich, your host for today, and in this video we are going to be doing the correction of the Cameroon GCE Advanced Level 2022 Computer Science Paper 3, precisely the programming section. So here we go. Here is my students folder named GC for all, and here is the question paper. As always, if you don't have the paper, you can download it from the GC4 website, which is linked in the description. And now if you scroll down to the programming section, you see our question, task 2 programming. Now here are the instructions. Unfortunately, they're quite lengthy, so I'm just going to give a summary on what it's about. Basically, we have to develop a function which prints prime numbers from the number 1 to a set number in a range which is going to be decided by the user. And in order to do that, we start by declaring an array called tab with an array size of 100. Now suppose the user enters the maximum value in the range as 10. You're going to fill the array tab with numbers from 1 to 10 as shown in this figure. Now we're going to set the first entry of the array, which is the entry 0, with the value 1 to 0, because obviously 1 is not a prime number. Now we're going to find the square root of n, and we're going to round the square root of n up. Supposing the user entered 10, the square root of 10 is about 3 point something. We're going to round that up to 4. Now we are going to identify 2 as the first prime number, and excluding 2 itself, we are going to set all the multiples of 2 to 0. In this range from 1 to 10, the multiples of 2 are 4, 6, 8, and 10. We are going to set them to 0. After that, you identify the next prime number in the range, which is 3. And we're going to do the same thing, set all its multiples to 0. In this range, multiples of 3 are 6 and 9. The next prime number in the range is 5, but 5 is greater than the root of n, so we have to stop there. Now we are going to print out all the non-zero numbers in the array, since they are going to be prime numbers. In this case, we see that all the non-zero numbers in the array are 2, 3, 5, and 7, and they are prime numbers. So with that in mind, we go to the application of the exercise. The application exercise says, in your answer booklet, state the programming language you will use. In our case, we are using C. Then give a more detailed version of the algorithm above in a pseudocode. In it, let n equals 20. So here is the pseudocode, you can pause, read. Now the second question says, write a subprogram called initialize, which takes in the arguments tab and n, that fills the array tab with numbers from 1 to n. So to do that, we go to our text editor, which is dev C++. In dev C++, we create a new source file, and we can start coding. We start by including our standard input library, hashtag include stdio.h. Then we move down to defining the first function. The question says the function initialize, which fills the array tab with values from 1 to n. So initialize, and the argument int tab, which is an array, and the next argument int n. Now to fill the array tab, we simply declare a for loop with conditions I starting from 0 to I being less than n, and we increment I. Tab I should be equal to I plus 1. Because the loop starts from 0, but the values in the tab array starts from 1. So with that done, that's basically it for the initialize function. So we move to the next question. The next question says, write a subprogram called verify prime with the parameter x that takes the number x and verify whether it's a prime number or not. For this, x is not divisible by any non-zero number less than it in the array tab. So to do that, we go back. To handle the condition of whether a number is a prime number or not, you can decide to use a certain form of Boolean methodology, where if the number is a prime number, then the function returns the integer 1, whereas if it's not a prime number, then the function returns integer 0. So in order to do that, we know that the function is going to have a return value of type integer, then the function name verify prime, which takes in the arguments int prime, int x, and int tab. In the verify prime function, we create a loop with conditions, the integer I starting from 0 to I less than x minus 1, that is every value less than x in the loop, and increment the I. Now in the for loop, we check if the value in tab I is not a non-zero number, that is, if tab I is not equal to 0, and if x divided by any number below it in the array tab is equal to 0, that is, x modulo tab I is equal to 0. If these two conditions are fulfilled, then the number is not a prime number. You have to return the value 0, implying it is not a prime number. Now if the number does not fulfill this condition, then the number is a prime number, then you can return the value 1. So with that done, that's basically it for the verify prime function. We move to the next part of the program. Question 4 says, write a subprogram called set0 with parameters tab n and y that takes a number y and sets all its multiples in array tab to 0 except the number itself, as explained earlier. The function doesn't have a return value, so void set0. It takes in the parameter the array tab, so int tab, int n, and finally int y. Now in the set0 function, you start by declaring a for loop with the condition for int I equal to 2 times y minus 1. That is because, take for example, if the integer y was 3, the position of y in the tab array is going to be 3 minus 1 because the array starts from 0 and the number starts from 1. Now excluding y, we are going to set all the multiples of y to 0. And the first multiple of y is obviously going to be 2 times y, as 3, the first multiple of 3 is going to be 2 times 3, which is 6. Now the position of 6 in the array is simply going to be 2 times 6 minus 1, which is the position 5, which is going to have the value 6. So that's why the loop starts from I equals to 2 times y minus 1, because that is the position of the first multiple of y. Then we proceed I less than n. Then the final condition is I plus equal to y. That is because we are going to continue incrementing I by y, since the first value of, say, the first value is going to be of I, say assuming assuming y is 3, the first multiple of 3 is 6 located in position 5. The second multiple of 3 is 9 located in position 8. So after calculating the first value of y, which is 5, we just keep adding 3 to 8, which is y in this case. That's why the third condition is I plus equal to y. We proceed in the for loop. We declare tab I equal to 0. That's why we're going to set that multiple to 0. Now question 5 says, write a subprogram called toDisplay with parameters tab and n that displays all non-zero elements of array tab up to those in array position n. We declare the toDisplay function. It doesn't return any value. The name toDisplay, and the arguments are going to be int tab, which is an array, and int n. Now in defining the toDisplay function, they say the function displays all non-zero numbers in the array tab. So I'm going to do a for loop for an integer I being equal to 1. That is because the array 0, which is number 1, has already been set to 0, so we can ignore it. I less than n, then I plus plus. Then I'm going to check if tab I is not equal to 0, that is if tab I is a non-zero number. Then we print tab I, so printf %d, comma tab I. And you can skip a space, so after every number there's a space printed for clarity. So basically for that we are done with the toDisplay function, and you can proceed to the next question. Now question 6 says, write a main program that makes use of the above subprograms to identify prime numbers in a positive integer range. Make sure your program works correctly. Start by declaring the main function int main void. Now in the main function, you declare the variables. These variables are going to be the array tab with an array size of 100, the number n, which is the maximum range entered by the user, and finally hood n, which is the root of the maximum range entered by the user. So in our text editor, write int tab with an array size of 100. The next variable is n, and finally hood n. Now we proceed. We're going to ask the user to enter the range he wants to print the prime numbers. So printf enter a, printf enter the max. So we say printf enter the max number for the range, or enter the max positive number for a range, in bracket maximum is equals to 100, since the array size is 100. Then we are going to scanf %d and n, that is, and the range capital N. With that done, we have to initialize the array tab. So initialize, the parameters will be tab and capital N. After we've initialized the array, we now set the tab 0 equal to 0. That's, we're going to set the first number 1 to 0. And after doing that, we have to find the root of n. So root n is equal to sqrtn. That is the function to find square root in C. But in order for us to use this function, we need to include the math header. So go back to the beginning and include hashtag include math.h. With that done, you can go back, and now this square root function should work. But now take, for example, the user enters n as 20. The square root of 20 is a fraction. So in order to make it to be an integer, we need to truncate it to an integer. To do that, you simply open brackets and put int before the square root function, and this should make any value which is the square root of n to be an integer. With that done, you go to the next line. After initializing tab n, you now declare a for loop for int I being equal to 1. Since we have already skipped the tab 0, then I less than n, I less than root n, then you have to increment I. Then in this for loop, so we're going to verify if tab I is a non-zero number. If that's the case, then we're going to set 0 tab I. We're going to set the multiples of tab I to 0. So set 0 tab n and tab I. Then now we do display. Now we display the values of the array, that is the prime numbers. So we call the do display function, which is going to take the parameters tab and n. So with this done, the function should pretty much work well. So we run it and see if you have any errors. First of all, proceed by saving. Please, in normal cases, you have to save. You have to have saved long before this. So here we have our first error, which says invalid required as int. Alright, so we made an error. That's supposed to be an if, not a for loop again. That wasn't even a loop. So you had to put the double equals to signs like conditional verification. Then in the set 0 function tab, we did not have to remove the n. And now everything works well. So let's say we enter the value 27. It's going to print prime numbers from 1 to 27, as you find there. The instructions say test your program with n equals to 100, save the output and print it. So we test the program with n being equal to 100, and now it has printed all prime numbers from 1 to 100. So with that done, you can do a screenshot of the program How's the craziest thing I've ever done? And save it in a Word document in our students folder, of course. So that's pretty much it about the correction of Cameroon GCE Advanced Level 2022 Computer Science Paper 3. That's the programming section. So as always, for those in the WhatsApp and Telegram group, this folder is going to be forwarded to you. And if you're with us up to this point in time, then a like on the video will be highly appreciated. Thank you all for watching, and see you again in the next one.